right, so we're starting a new chapter, and today's lesson is on proportions. This word should sound familiar to you from past math classes. Definition of a proportion is two ratios set equal to each other. So first we need to see what a ratio is. A ratio is a comparison of two quantities. So quantity means amount of something. Okay, so keep that in mind. It has to be two amounts of something. We can write a ratio in a couple of ways. We can say it the ratio of A to B, and it can be written or expressed as A colon B. So if we say something's in a ratio of 2 to 3, then we would write 2 colon 3. Or we can write it as a fraction, 2 over 3. Now remember, in a fraction, the denominator cannot ever be 0. So whatever you're comparing to, the second quantity, it can't be 0. And again, if you think about that logically, if you're comparing quantities, amounts of something, and you have an amount of 0, then there's nothing there to compare to. So you couldn't have a ratio because you're not comparing it to anything. Okay, so just be familiar with these two ways of writing a ratio. They are both equally correct. Okay, so you would read them both A to B. You also write ratios. You might hear the word per in your question or in your description. The word per means that you're setting up a fraction or a ratio. You're comparing two quantities. Again, for example, miles per hour. You would write miles per hour, miles on top, hours on bottom. Okay, per means you're making a comparison. Two quantities, how many miles in how many hours. Your cell phone bill may show you the ratio of cents to minutes, 10 cents per minute. Okay, that is a comparison of two quantities, therefore it is a ratio. A recipe, you might use 1 cup of flour to every half a cup of sugar. Okay, so your ratio, 1 to 1/2. Okay, lots of different places where you see ratios. Here's another example. Gary has a bag of 4 marbles, 3 books, 5 pencils, and 2 erasers. So first we want to write a ratio of pencils to books. Now the order here is very important. Pencils comes first, books come second. So we're going to write our ratio in the same order. So we go back up here to our problem and we say, okay, find our pencils. How many pencils do we have? 5. Okay, so I'm going to write the 5 first. 2, remember, can be a colon or a fraction bar. And then how many books does he have? 3. So our ratio could be written 5 to 3, or it could be written as a fraction, 5 over 3. Either way is correct. Do not write it 3 to 5. Okay, because it's not worded that way, you would not be indicating the correct ratio there. What is the ratio of marbles to the total number of items in the bag? Again, it might be helpful to underline the two parts, total items. Okay, so I'm going to do marbles first. I come up here, find marbles. I have 4. Then 2 indicates a ratio. Total number of items. Well, what am I going to have to do here if I want the total? I have to add them up, right? So I have 7 and 7, that's 14. Okay, now if I were to write that as a fraction, 4 over 14, is this the simplest way to write that fraction? No, it's not, because I can reduce it. Each one of these is divisible by 2, so I would really want to write it in simplest form, 2 over 7. Okay, so you always want to reduce. Always reduce. So start off 4 over 14. Always ask yourself, can I reduce this in some way? And reduce it. Again, you could write it as a fraction, 2 over 7. Either way, equally acceptable. Okay, so let's do this word problem. A total number of students who participate in sports programs at Central High School is 500. The total number of students in the school is 2,000. So 500 participate in sports, a total of 2,000. What is the athlete to student ratio to the nearest tenth? Okay, so I want my athletes first. 500 people participate in sports. That makes them an athlete. Okay, wording a little different, but it means the same thing. 2 means I make a fraction out of it. And student, how many students are there? 2,000. Okay, my zeros cancel here. Don't make the mistake of dividing backwards. This is not 20 divided by 5. This is 5 divided by 20. The answer is not 4. I see that a lot. If you were to divide this out, it would look like this in long division. Okay, you're going to have to put your decimal and so on. 40. Bring down your other 0. So the answer is 0.25, but look, it says to the nearest tenth. Where's the tenths place here? The 2 is the tenths place. So if I put 0.25, in order to round to the tenths, I have to look to the next one over and round back. If this is 5 or bigger, then I need to increase my number 0.3. Again, this is just number sense that you should be familiar with. Okay, on the computer it's a little bit neater. Looks like so. Okay, so again you could write it as 1/4 or 1 to 4, but the instructions said to the nearest tenth, so we need to divide that out and make it a decimal. Rounded to the nearest tenth is 0.3. So always go back up to your question and make sure you're answering the question correctly. Working too fast can get you in trouble sometimes. Okay, here's another way to use ratios. The perimeter of a rectangle is 60. Okay, what is perimeter? Need to know that word. Remember, it's the distance all the way around. The ratio of AB to BC, so length to width, is 3 to 2. Find the length and width of the rectangle. So what numbers can we put in here for our length and our width so that it has a 3 to 2 ratio? That doesn't mean that it is 3 and 2. It just means when you reduce it, it reduces to 3 to 2. That's the lowest terms. So the actual ratio or actual numbers could be 6 and 4. Or 9 and 6, or 12 and 8, and so on. All of these reduce to 3 to 2, or 3 over 2. We got to figure out which of these can I plug in here so that they add up to 60. Okay, well here's how I'm going to set this up. I know that this ratio of 3 to 2 is going to be multiplied by the same number. Okay, here I multiplied both of them by 2. Okay, here I multiplied both of them by 3. Here I multiplied both of them by 4, and so on. I could multiply by 5 and get 15 to 10. Either way, I'm multiplying both of these numbers by the same number. I don't know what that number is, so I need to call it x. Okay, so we could write that in here. This is 3x for my length, 2x for my width. Okay, Now, how am I going to use that? Well, I know that my perimeter is 60. Again, what is perimeter? It's the distance all the way around. It's 2 of the lengths plus 2 of the widths. Or you could write it like this, 2 times length plus width. You should know the formula for the perimeter of a rectangle. Okay, this is past information that I'm expecting you to already know. So now I plug in. Well, what was my length called? It was called 3x. So length here is 3x. Width here is 2x. I need to add my like terms. I get 5x times 2 gives me 10x. So if you need to write that step in, write it in so you know where these numbers came from. Divide by 10 on both sides, and I get x equals 6. Now, is that the answer to my question? Again, get in the habit of going back up here and reading again. Find the length and width of the rectangle. Okay, so I know that they are represented by 3x and 2x. Now I know that x is 6, so I need to plug that in. All right, so here's my length. 3 times x becomes 3 times 6. Okay, this is where the 6 came from, which is 18. 2 times x becomes 2 times 6, which is 12. So these are my answers. The angle measures of triangle ABC are in the ratio of 2 to 3 to 4. Again, that doesn't mean that these numbers are 2, 3, and 4. It means that when reduced, it becomes 2, 3, and 4. So again, it could be, if I multiplied all these by 2, I would get 4, 6, and 8. If I multiplied them by 3, I would get 6, 9, and 12. It could be anything as long as these are multiplied by the same number. It could be 20, 30, and 40 by multiplying them each by 10. But the reduced ratio is 2 to 3 to 4. So I need to put an x behind each one of those numbers to represent my angles. Okay, so I'm going to say 2x, 3x, 4x. I'm multiplying them all three by the same number. I just don't know what that number is yet. Now, let's think about this. I have all these x's, so I can put them in the same equation. What I need to know is what is the ratio or the relationship between those three angles. Am I told that any of them are equal to each other? No, there's no congruency marks. Nothing in my question tells me. But I do know that all three angles of a triangle do what? Add up to 180 degrees. All right, that's the triangle sum theorem. So now I replace each angle with the representation we've written inside the diagram. I'll set it equal to 180. Add my like terms. 4 plus 3 is 7, plus 2 is 9. Divide by 9, and x equals 20. Does that answer my question? Find the measure of the three angles. Nope. So I need to go plug this 20 in here for x, here for x, and here for x. And when I do that, I answer my question. So angle A will equal 40. 2 times 20 is 40. Angle B is backwards. Okay. B and C should be switched. So angle B, we'll make this angle C for the purpose of this slideshow, is 3 times 20. And we'll make this an angle B, which is 40. 4 times 20 is 80. I'm sorry, 4 times 20 is 80. Okay, totally messed that up, didn't I? Sorry, guys. Now, if I put two ratios equal to each other, I get what's called a proportion. Right? Two equivalent ratios set equal to each other. They have to be equivalent. That doesn't mean the exact same numbers. It just means that when you reduce them or divide them, you get the same number. If I divide 3 by 4, I get 0.75. If I divide 6 by 8, I get 0.75. They are equivalent, though they don't look the same. I can reduce 6 over 8 to 3 over 4. To know if they are equal to each other, you can look at what's called their cross products. Just what it sounds like. You need to know that term. It's like cross multiplying. The two things that you multiply together are called products. You get the product, right? And you're doing it in a cross or an X. So they would be equal if the ratio is set equal to each other. So here we go. We're going to multiply from the bottom up. 8 times 3 is 24. 4 times 6 is 24. Because I got the same answer, that means that these two ratios are equal to each other, and this is a true proportion. Some new vocab words that you probably haven't heard before are means and extremes. Okay, these four numbers have names because of their position. These that are connected by this yellow greenish line here, these are called the extremes. They're like the first one you would write and the last one you would write. So they're on the outside, kind of, if you think of it that way. So they're the extremes. Then the middle two, connected by this red line, are called the means. So you need to be able to identify which one are the means and which ones are the extremes. Which one are the means? Which one are the extremes? Okay, know those words, be able to identify them. So let's use our cross products here. Cross products again can be used to compare fractions to determine if they're equal or not. If the cross products are equal, the fractions are equal. If the cross products are not equal, the fractions are not equal. So let's look at this example here. We have 2 over 3, 4 over 5. We're going to multiply from the bottom up. 5 times 2 is 10. 3 times 4 is 12. Are those equal? Obviously not. So how would I set up an inequality? How would I know which one's bigger, which one's smaller? Well, if you multiply from the bottom up, then they are in order. The 10 goes with the 2/3, the 12 goes with the 4/5, so 2/3 is less than 4/5. Okay, 10 is less than 12, here we have it, therefore 2/3 is less than 4/5. But this only works if you multiply from the bottom up. So make sure you remember to always multiply upward. Okay, we can also use cross products to find an unknown value. If we didn't know the 4 here, well, that's probably not a good example. In a true equal proportion, we can use it to find an unknown. Okay, and we'll do some of those here in a minute. Let's go through these and see if these are true proportions. Is 4/5 equal to 8/10? Many of you can just look at this immediately and say, yes, this reduces to 4 over 5. Some of you don't see it quite so easily. If we do the cross products, again, from the bottom upward, 5 times 8 is 40. 10 times 4 is 40. So is this a true proportion? Are my ratios equal to each other? Yes, they are. They're both 40. How about example B? 4 times 12 is, 8 times 6 is, are they equal? Is it a true proportion? Yes, it is. On to example C. 8 times 12, 96, if you don't know that in your head. 6 times 4, you should know that in your head. Are those equal? No, they are not. So this is not a true proportion. Okay, how about D? 12 times 3, 6 times 6. Again, we're going from the bottom up. 12 times 3, 6 times 6. Okay, example E. From the bottom up, what's 12 times 6? From the bottom up, what's 8 times 4? Is this a true proportion? No. Last one. 4 times 12. 6 times 8. Proportion? Yes. Let's look at these two that were not true proportions. Because they're not equal, I can't put this equal sign there. I need to figure out, is it going to be a less than or an equal than sign here? Again, because I went from the bottom up, I can simply compare these two numbers in the order that they are and write the appropriate inequality sign. So no equal sign, it should be less than. 4/12 is less than 6/8. Same thing up here. 4/8 is going to be less than 12/6 because 24 is less than 96. And if you reduced them, you could see that too. 4/8 reduces to 1/2. 12/6 reduces to 2. Well, obviously half is less than 2. Okay, so whatever, again, this is 1/3. What goes into 6 and 8? 2. So it reduces to 3/4. Okay, 1/3 of something is going to be less than 3/4 of something. So several ways to analyze these fractions to see if they're true proportions or not, and to determine which one's bigger than the next. So proportions can also be used to find unknown values. Let's do that. If Sally can run 10 meters in 45 seconds, how far will she run in 80 seconds? So I need to set up two ratios equal to each other. I'm going to set meters equal to meters and seconds equal to seconds. Same units equal to each other. On the left-hand side, I'm going to use the first situation in my problem, and on the right-hand side, I'm going to use the second situation in my problem. Okay, so let's go through this one step at a time. How many meters do I have in my first situation? 10. That's what comes first. How many meters do I have in my second situation? We don't have any meters here. It says, how far will she run? I don't know. Therefore, I'm going to call that X. So I now have 10 meters for my first situation, X meters for my second situation. Now I go to my time, my seconds. I have 45 seconds in my first situation that goes with the 10 meters, so they go in the same fraction. It's 10 meters per 45 seconds, same fraction. And I have 80 seconds that goes with my unknown distance here. So now I have a proportion. In order for these two ratios to be equal, there's only one number that can go here, and I can use my cross products to figure out what that answer is. So when I multiply 80 times 10, and 45 times x. I'm going to set those two numbers equal to each other. I get 800 meters here, meter seconds, because I have meters and seconds. And that's going to equal 45x meter seconds. Now remember, I'm just trying to solve for this x right here. So I need to get rid of this 45. This ms, these are just units, like miles or inches or hours. Okay, they're not part of our calculation, but they do cancel. Okay, so if I divide by 45 seconds, which is what's up here, 45 seconds, I cancel out both the 45 and the seconds. The seconds cancel out. You'll use this in chemistry and in physics where you cancel your units out. You can catch so many mistakes if you learn to carry your units all the way through your calculations, canceling out whatever's on top with whatever's on bottom. It has to be a 1-to-1. One has to be on top, one has to be on bottom in order to cancel it out. So what is left? What is left is 800 divided by 45, and I have meters. Then over here I have x meters. So when I do the division, 800 divided by 45, I get 17.8 meters equals, on the other side here, x meters. So how far can she run? She can run 17.8 meters. So use your cross products. Let's do one more. A boxcar on a train has a length of 40 feet and a width of 9 feet. A scale model is made with the length of 16 inches. Find the width of the model. Okay, so again, I have first situation, second situation. First situation is the one that's given to us first in the problem. Okay, so I'm going to compare length to length. Got to compare same things. Okay, so I have the length here in feet, and I'm going to compare it to the length in inches. The width in feet, I'm going to compare it to the width in inches. So we go back up to our problem and we plug it in. Here I have the boxcar length in feet is 40 feet. In inches, it's 16 inches. Now let's compare the widths. Because I compared the length of the first part, I got to compare the width of the first part up here. Feet have to go with feet. Inches have to go with inches. So you got to match the right parts up here. That's the trick. You all know how to cross multiply. You know how to solve for the x here. It's getting everything in the right position of your proportion. That's the trick. So the original boxcar width in feet was 9. And the new width is what we're looking for in inches. Okay, so I just substituted in all these numbers that were given to us into my situation here. Now I'm going to cross multiply, and I get 40x and 16 times 9. 16 times 9 is 144. Then when I divide by 40, my x is 3.6. 3.6. What? I need a label here. Well, my x was down here. What units did I have here? I had inches. So I automatically know to label my answer in inches. Always label your answer and then box it in. All right, so there's a couple of examples of how we can use proportions. I hope you do well on your practice.